Okay, hi everyone, welcome back to the Comptia Security Plus course. SNMP, the Simple Network Management Protocol. SNMP is a TCP/IP protocol that aids in monitoring network attached devices and computers. It's usually incorporated as part of a network management system such as Windows SCCM, SCOM, or free SNMP based monitoring software. A typical scenario that uses SNMP can be broken down into three components: managed devices, computers or other network attached devices monitored through the use of agents by a network management system. Agent, software deployed by the network management system that is loaded on managed devices. The software redirects the information that the NMS needs to monitor the remote managed devices network management system, NMS. The software run on one or more servers that controls the monitoring of network attached devices and computers. So if the IT director asked you to install agents on several computers and network printers and monitor them from the server, this would be an example of SNMP and the use of a network management system. SNMP uses ports 161 and 162. SNMP agents receive requests on port 161. These requests come from the network management system or simply manager. The manager receives notifications on port 162 because applications that use SNMP versions 1 and 2 are less secure and they should be replaced by software that supports SNMP version 3 or whatever the latest version is. SNMP v3 provides confidentiality through the use of encrypted packets that prevent snooping and provide additional message integrity and authentication. However, there are vulnerabilities such as distribution units, PDUs, monitored by SNMP that use weak symmetric algorithms like CBCDES. Packet analyzers and other third-party programs can be used to analyze SNMP devices, their packets, and any potential vulnerabilities. Historically, SNMP-based monitoring and management tools have been in-band, meaning that the admin connects locally through the main company network itself. In-band management is very common. However, an admin might find the need to take an alternative path to manage network devices. In this case, the admin requires out-of-band management. This is common for devices that do not have a direct network connection, such as UPS, PBX systems, and environmental controls. More importantly, in a mission-critical network, SNMP-based in-band management tools are not enough, because if the main LAN fails, then there is no path to manage the devices. That's when out-of-band management becomes crucial. Out-of-band tools that are based on RS-232 access or even an entirely separate LAN are required if the main network fails. The key here is that an access switch of some kind that is independent from the main in-band network is available to the managed devices. The decision whether to use in-band or out-of-band management to both should be weighed carefully. Remember that every additional system or network increases the security risk and needs to be protected appropriately on a physical and a logical level. This then needs to be balanced against the level of criticality of your systems. Analytical tools. When trying to distinguish between monitoring, auditing, vulnerability assessments, and forensics, but from a hands-on point of view, they are all quite similar. Many analytical tools can be used for multiple security purposes. This section discusses a few more tools that are more fine-tuned for monitoring, but that doesn't mean that they can't be used for other security purposes, and there are plenty of other tools not mentioned here that can also be used for monitoring. You'll probably want to monitor open sessions and files in Windows. Any files and shares that are being accessed by remote computers can be monitored within computer management. COM/PM/GMT.MSC. Inside computer management, navigate to System Tools, Shared Folders. From there you can see what shares and open files are being accessed and what network sessions are open to that computer. One thing you can't see in this utility is the files that were opened locally, but for this you can use the Open Files command, which also allows you to see files opened by remote computers. The Open Files command must be run in elevated mode within command prompt, and by default the main objects list global flag must be enabled, which can be done within the following syntax: open files /local on, then simply run the Open Files command to see what files are opened locally and by remote computers as shown in figure 13.4. Of course, there are switches that you can use to modify command. View them with the / option. You might have to increase the screen buffer for the command prompt to see all of the results. As you can see in the figure, there is a long list of locally accessed files, but more importantly, the second list starting with ID2 shows any files that remote computers are connected to. You can also use open files to disconnect those remote computers. Example syntax: open files /disconnect /ID ##, where the ## is the ID number associated with the file shown at the left of the figure. You might also find that files have been opened and possibly compromised. When you are not sure if the integrity of a file or files has been affected, you can use the FC command to compare the file that is suspected of compromise with an older version of the file. Files can also be viewed and closed with the net file command. Must be run in elevated mode. You will probably also want to make use of the net config, net session and net view commands. Better yet, just know the whole net command like the back of your hand. And of course there's the netstat command. For example, netstat -an is a good way to show open ports in numeric format, and netstat -e gives the amount of bytes and packets and errors sent and received. We previously mentioned a few commands in Linux that can be used to view processes, services and open files. Another command that can be used to show open files is ones of list open files. The netstat command functions similarly in Linux as it does in Windows, with netstat -1 I think being very informative. Changing gears somewhat, what makes up a lot of the files stored on servers, individual keystrokes, a bunch of them, and these too can be monitored with EY loggers, both hardware and software based. The hardware variety is usually an inline or pass-through device that connects to the end of a keyboard cable just before the port on the computer. These are tricky little devices that often look like a basic adapter, but in reality they are fairly inexpensive devices that can store gigabytes of data and can transmit data wirelessly. You can identify a potential keylogger by the fact that it has the same port on each end, albeit one male and one female. Often They are heavier than a basic adapter of similar size due to the additional processors and the antennas that are built in. The basic countermeasures for these is to deny physical access to areas of the building with important data such as server rooms. If people have free access to your building, then there is a definite vulnerability. As a security administrator, you should lobby against such access, but if it is inescapable, then a thorough visual search of computers should be periodically undertaken. Sometimes a computer's ports cannot be visualized very easily, but have no fear, there are software tools that can be used to locate these physical keyloggers as well. Speaking of software tools, keyloggers come in software format as well, and some are very difficult to detect, such as actual keylogger. These software tools can be prevented by using anti-keylogger software and security tokens. These can be detected by using live USB, CD, DVD operating systems and network monitoring programs. Use static and dynamic tools. The list of analytical tools goes on and on, both integrated into the operating system and offered by third parties. Most of the analytical tools discussed in this section are static in nature. Because of this, they are not best suited for monitoring environments where you are attempting to create a baseline. Other more dynamic tools such as Performance Monitor and Wireshark will work better. However, there is something to be said about taking a snapshot of the moment with such tools as Open Files and getting a quick glimpse at what happens at just that moment. Taking it to the next level is the combination of static and dynamic tools that will allow you to properly conduct an audit. Conducting audits. Computer security audits are technical assessments conducted on applications, systems, or networks. They are an example of a detective security control. Audits can be done manually or with computer programs. Manual assessments usually include the following: review of security logs, review of access control lists, review of user rights and permissions, review of group policies, performance of vulnerability scans, review of written organization policies, interviewing organization personnel. Programs used to audit a computer or network could be as simple as a program such as Belarc Advisor or built-in auditing features within Windows and Linux, or more complex open source projects such as OpenXDAS. When I have conducted IT security audits in the past, the following basic steps have helped me organize the entire process: define exactly what is to be audited, create backups, scan for, analyze and create a list of vulnerabilities, threats and issues that have already occurred, calculate risk, develop a plan to mitigate risk and present it to the appropriate personnel. Although an independent security auditor might do all things, a security administrator will be most concerned with the auditing of files, logs and system security settings. Auditing files. When dealing with auditing, we are interested in the who, what and when. Basically, a security administrator wants to know who did what to a particular resource and when that person did it. Auditing files can usually be broken down into 3 processes. Step 1, turn on an auditing policy. Step 2, enable auditing for particular objects such as files, folders and printers. Step 3, review the security logs to determine who did what to a resource and when. As an example, let's use a Windows client computer. First, we would need to turn on a specific auditing policy such as audit object access. This can be done within the local security policy as shown in figure 13.5. You can select from several different auditing policies such as long on events and privilege use. but object access is probably the most common, so we'll use that as an example. As an example, let's use a Windows client computer. First, we need to turn on a specific auditing policy such as audit object access. This can be done within the local computer policy as shown in figure 13.5. You can select from several different auditing policies such as logon events and privilege use, but object access is probably the most common, so we'll use that as an example. Next, we would need to enable auditing for particular objects. Let's say that we are auditing a folder of data. We would want to go to the Properties dialog box for that folder, then navigate to the Security tab, then click the Advanced button, and finally access the Auditing tab as shown in figure 13.6. From there, we can add users whom we want to audit, and we can specify one or more of many different attributes to be audited. Finally, we need to review the security logs to see exactly what is happening on our system and who is accessing what and when. The security logs also tell us whether users have succeeded or failed in their attempts to access, modify or delete objects. And if the users deny what they attempted to do, the logs act as a proof that their user account was indeed involved. This is one of several ways of putting non-repudiation into force. Non-repudiation is the idea of ensuring that a person or group cannot refute the validity of your proof against them. A common problem with security logs is that they fail to become populated, especially on older systems. If users complain to you that they cannot see any security events in the event viewer, you should ask yourself the following: has the audit been turned on in a policy, and what is turned on in the correct policy? Was auditing enabled for the individual object? Does the person attempting to view the log have administrative capabilities? In addition, you have to watch out for overriding policies. By default, a policy gets its setting from a parent policy. You might need to turn off the override option. On another note, perhaps the audit recording failed for some reason. Many auditing systems also have the capability to send an alert to the administrator in case that the recording fails. Hopefully, the systems attempting to recover from the failure and continue recording auditing information while the administrator fixes the issue. By answering all of these questions and examining everything pertinent to the auditing scenario, you should be able to populate the security log. Now, security logs are just one component of logging that we cover in the next section, logging. When it comes to auditing an organized set of information, logging is the method of choice. Frequent monitoring of logs is an important part of being a security person. Possibly the most important log file in the Windows is the security log file as shown in figure 13.7. The security log can show whether a user was successful at doing a variety of things, including logging onto the local computer or domain, accessing, modifying or deleting files, modifying policies, and so on. Of course, many of these things need to be configured first before they can be logged. Newer versions of Windows automatically log events such as log on and policy modification. All these security log events can be referred to as audit trails. Audit trails are records of logs that show the tracked actions of users, whether the user was successful in an attempt or not. A security administrator should monitor this log file often to keep on top of any breaches or attempted breaches of security. By periodically reviewing the logs of applications, operating systems and network devices, we can find issues, errors and threats quickly and increase our general awareness of the state of the network. Several other types of Windows log files should be monitored periodically, including the following. System log events such as system shutdown or driver failure, application log events for operating system applications and third-party programs. The system and application logs exist on client and server versions of Windows. A few log files that exist only on servers include the following: distributed file system DFS, replication service or file replication service, DNS service, directory service. The distributed file system DFS replication log or file replication service log on older versions of Windows Server exists on Windows servers by default. However, the directory service log will appear if the server has been promoted to a domain controller, and the DNS log will appear only if the DNS service has been installed on the server. Figure 13.8 shows the logs that run on a Windows server that has been promoted to a domain controller and is running DNS. We've mentioned the importance of reviewing DNS logs previously in the book, but it is worth reminding you that examining the DNS log can uncover unauthorized zone transfers and other malicious or inadvertent activity on the DNS server. In the case of figure 13.8, we can see a warning stating that Active Directory Domain Services ADDS has not signaled to DNS that synchronization of the directory has completed. We'll have to investigate that and probably fix that manually. Let's not forget about web servers and analyzing and monitoring a web server. You can determine whether the server has been compromised. Drops in CPU and hard disk speed are common indications of a web server that has been attacked. Of course, it could just be a whole lot of web traffic. It's up to you to use the logs to find out exactly what is going on. Other types of operating system applications and devices have their own set of log files. For example, applications such as Microsoft Exchange, SQL database servers and firewalls. The firewall log especially is of importance as shown in figure 13.9. Note in the figure the dropped packets from address on the 169.254.0.0 network, which is also known to be the IPA network number. This is something that should be investigated further because most organizations have a policy against the policy against the use of IPA addresses. The firewall log can show all kinds of other things such as malicious port scans and other vulnerability scans. For example, when digging into the firewall log event, if you can see the following syntax, you should note that a port scan attack has occurred. Note that the source IP address, which is public and therefore most likely external to your network, uses port 53 outbound to run a port scan of 10.1.1.80, starting with port 0 and moving on from there. The firewall is usually the first line of defense, but even if you have an IDS or IPS in front of it, you should review those firewall logs often. A very useful tool for the security administrator is syslog. Syslog is standard for computer message logging. Most devices such as switches, routers and firewalls use it or can be updated to use it. For example, the log in figure 13.9 was generated while adhering to the syslog protocol. In addition, the log can be exported in real time to a computer running a syslog server. The syslog server is really just a repository for logs that already exist on your routers and other devices. The key is that the syslog server can run directly on your workstation and pull the logs from those devices, so you can easily monitor what is happening on those devices from the comfort of your seat. Yes, you could check the logs by logging into the router or other devices, but the logs won't be readily available. You will have to locate them, and many different devices will store them in different places. With a syslog server, you can view multi-devices logs from one screen. To illustrate this technology in action, take a look at figure 1310. This shows a syslog program that is getting a log fed to it from a SOHO router. You can see that it is very easy to read the details of that log within the syslog program, much easier than it would be to read them from within the SOHO router's interface. Figure 1310 shows a list of logs. The one at the top is highlighted. It shows that the source IP is 10.254.254.1. That is the internal IP address of the SOHO router, the device that is creating the log, and the one that is being monitored. The highlighted entry also has the details at the bottom of the screen. You can see that the SOHO router blocked a TCP packet from the IP address 64.233.171.188, in this case from port 5228. This is real and it happens all the time, as you can see from the log. It really reinforces the fact that you need to make sure your router or other device has its ports closed and is patched and up to date. By default, syslog uses port 514 and works over a UDP transport mechanism. There are several companies that offer syslog programs: SolarWinds, KIWI and Syslog Watcher, for example, and they all work in basically the same way through the use of a proprietary port number instead of the standard 514, and may offer TCP connectivity as well to avoid packet loss. Port 6514 is used for secure connections known as syslog over TLS. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.